This short video will demonstrate how the StealthWatch solution will help detect an insider threat. The Verizon Data Breach Report shows findings that 76% of breaches involve stolen credentials and 14% of the breaches were perpetrated by insiders. In order to be able to protect data and intellectual property, it is critical that you not only monitor user authentication records, but associate these login records to the network traffic. Insider threat could be a disgruntled employee, person about to leave the company and wants to take data with them, a person with privileged credentials with access to more data than needed, or a person stealing and selling trade secrets to make a profit. Let's walk through an insider threat detected by StealthWatch using internal visibility provided by collecting and analyzing flow data. Lucy logs in from 10.201.3.18 and connects to a terminal server within the data center. This provides local access within the data center to connect to other servers. From the terminal server, Lucy connects to a database within the same subnet and pulls down 38 gigs of information. This information is staged and encrypted. This is an important note as the method StealthWatch uses for detection allows for identifying a threat even if the data is encrypted. The traffic was tunneled through UDP port 53 using a peer-to-peer file sharing application to an outside host of 74.213.99.97. An insider threat dashboard was built to help focus on lateral movement within the organization and concentrates on security events designed to catch internal data loss and exfiltration. We've accounted for every packet sent and received within the network, server to server within the same data center, or host to host within a site, segment, or VLAN. There was over 1.15 terabytes of internal data transferred. You can also see that there was a SQL traffic spike just before 9 a.m. and visibility into all traffic that's traversing from within the network. StealthWatch audits any data sent and received from an internal host in addition to any data sent outside of the network. An alarm will trigger on any data hoarding, which is host downloading information from internal servers, and data exfiltration, which would be data being sent out of the network. The pie chart illustrates the top insider threat. Looking at the insider threat details, we see that there are a handful of alarms that have triggered. Suspect data hoarding indicates that a source host has downloaded an unusual amount of information from one or more internal hosts. Suspect data loss indicates that the source host has uploaded an unusual amount of data out to an external host. Fake application indicates a mismatch between the detected application and the TCP or UDP port that is being used. This could indicate application tunneling. The source column tells you which host initiated the alarm. The details provide information about the specific alarms, such as the learned and expected value or policy maximums versus the observed value. The policy maximum prevents overlearning behavior to detect threats. Mitigation may be enabled to send a block action to an inline device, such as an ASA firewall, or a null zero to a router, or quarantine action to a Cisco Identity Services engine. Getting more details on 10.201.0.23, who has triggered the fake application and suspect data loss event, we were able to identify the user information that is associated with this event. We see that Lucy is logged in to a Windows 2003 server. And viewing the security events outlines the stages of the attack, starting with the data hoarding event, which led into a high total traffic and then a fake application event over port 53, which is when the traffic began to be tunneled, and this led to a data loss event. During each stage of the attack, StealthWatch generated an alert on the behavior changes, which would have allowed for stopping the user before it led to data loss condition. Pulling back associated flows around the timing of the security events allows for a clear understanding of the traffic between hosts. Notice the application tunneling of a peer-to-peer file sharing application being used through port 53, where multi-gigs of data is being sent to a host in Puerto Rico. Looking back at the traffic graph on the insider threat dashboard, you're able to click on any unusual traffic pattern, such as the large SQL spike. This will show you the host associated with the large spike that occurred on the graph. In summary, this flow table visual outlines the stages of the insider threat, starting from a user logging into a terminal server to get within the data center. Data is pulled from the database and the data is tunneled to an internet host. As you can see, StealthWatch provides a complete audit trail of the conversations that occurred from within the network. Joining user login information to all network transactions allows for StealthWatch the ability to detect insider threats that occur by users stealing from within the network and/or pushing data out of the network. The user cannot hide from the network, and through flow collection and behavioral analytics, you're able to detect insider threats.